So we got this situation to handle. Let f defined from R to R and g defined from R to R be two functions such that g of x is this, g of f of x is this. Then the value of f of 2 plus lambda minus lambda 2 is. Now, first try to understand this concept as, because in this question they didn't provided you f of x so that you can proceed. Means if they will give you f of x, g of x, you can find out g of f of x or f of g of x easily. But they skipped the level 2 and directly they reached at level 3 and they're asking you question about level 2. Okay, now my point is, suppose that just focus on the observation how f of g of x behaves. So suppose that f of x is 2-degree polynomial, and suppose that g of x is also 2-degree polynomial. Okay, so if you will find out f of g of x, you will be having 4-degree polynomial, because in place of x of f of x you will be writing g of x. So it will become x square power 2, it will become 4. Means, can I say that? Okay, I'll wait and then later I'll say. Now, suppose that in case 2, g of x is 3-degree polynomial. So in this part, f of g of x will become what? It will become x cube power 2, means 6, x power 6. Now I will tell you something which you have to understand with better clarity. So suppose that f of x is 2-degree polynomial, g of x is 2-degree polynomial, then f of g of x will become 4-degree polynomial. So can you establish a relationship between the degree of the polynomial? That, sir, I feel that the degree of the composite function depends upon the product of degree of f of x and g of x, because in second case you have taken f of x as 2-degree polynomial, g of x is 3-degree polynomial. So if we'll multiply 2 and 3, we will get 6, and which is the degree of f of g of x. Okay, so therefore you can connect with the degree of the polynomial. Now look at here, these guys have given you g of x as x cube plus x minus 1. Now think about f of x so that you will get f of g of f of x as 3-degree polynomial. So it is only possible if f of x will be a linear polynomial ax plus b. Look, degree of first polynomial is 3, degree of second polynomial is 1. So 3 into 1 is 3. So g of f of x is having 3-degree polynomial, we can connect. Okay. Now my point is, now just leave the question and focus on your g of f of x. So g of f of x will become what? You have to replace x of g with f of x. So you will be writing f of x cube plus f of x minus 1. Now just replace it with ax plus b. So ax plus b cube plus ax plus b minus 1. Now a cube x cube means I'm applying a plus b whole cube. So a cube plus b cube plus 3 a square b plus 3 b square a plus ax plus b minus 1. Now what I will do? I will segregate things. Means first I will be writing leading coefficient, means the coefficient of x cube. So we will get x cube over here only. So it is a cube x cube. Now I am writing a square. So a square is available only here. So it is 3 times, means I am writing x coefficient of x square. 3 a square b and then x square. Now I want to go with the linear. So linear will be taken from here and here. So it is 3b square a plus a and then we have x. Now plus b cube plus b minus 1. Okay. So we got g of f of x. G of f of x. Now according to us, g of f of x is this. According to them, g of f of x is this. Now we guys can compare the coefficient to get the respective arbitrary constant values. Okay, so first focus on the leading coefficient x cube. So according to us, the coefficient of x cube is a cube. According to them, coefficient of x cube is 27. So we got result as a equals to 3. Okay, so the value of a is 3. Now focus on coefficient of x square. So it is 3 a square b. So according to us, coefficient of x square is 3 a square b. According to them, it is minus of lambda 1. So minus of lambda 1. Now a is what? A is 3. So it is 27 b. We don't know who is b. So lambda 1 will be minus of 27 b. We will find out the value of b or the lambda 1 so that we can get the result done. So we will wait for time being. Now let's move on to the coefficient of x. So according to us, coefficient of x is 3b square a plus a is equal to, so according to us, the coefficient of x is this. According to them, coefficient of x is 39. So 39. Now let's simplify things. So we have a as 3. So it is 9 times b square plus 3 equals to 39. So 3 that side will become 36. We have 9b square. So we got b square as 4. So b value will be 2 or b value will be minus 2. So we have to decide. Now be super slow and look at this. These guys are saying that lambda 1 is a positive number. So when lambda 1 will be positive number? If b is a negative. If b will be negative, then negative into negative will become positive. So according to me, the value of b is minus 2. So it will become 54. So lambda 1 is 54. I hope till this part you guys are comfortable. Now we will move on to the constant part. So according to us, constant part is b cube plus b minus 1. According to them, constant part is lambda 2. So let's evaluate the value of lambda 2. So it is minus 2 minus 2 ka cube is minus of 8 minus of 2 minus of 1. So lambda 2. So the value of lambda 2 is minus of 11. We got lambda 2 as minus of 11. Also these guys are saying that lambda 2 is a negative number, so it's okay. We got our things done. Now what is the required value? Required value is f of 2 plus lambda 1 minus lambda 2. So who is f of x? F of x was ax plus b. Okay, so a was 3, ax plus b, so minus 2. So f of 2 will become what? F of 2 we will be having 6 minus 2, that is 4. Now let's substitute. So 4 lambda 1 is what? 54, and lambda 2 is what? Minus of 11. So minus of minus 11 will become plus of 11. So it is 58, 59, 69. So the value of the required thing is 69. I hope you got the idea, you got the approach. Only in this question you have learned this beautiful concept, and rest is just a procedural part. Okay.